So we've got to simplify this expression. Now, it's 5 times x to the power of 5 times y to the power of 4 times z over 30 times x to the power of 3 times y times z to the power of 2. So you can do what's called the quotient rule and just subtract with the exponents. But what I propose, especially when we're just starting out with exponents, let's just expand them all and then cross cancel so we can see what we're doing. Perhaps afterwards I'll use the quotient rule just to show you, and so we can see both ways. But the simplest way is just to rewrite it. So x to the power of 5 is how many x's being multiplied out. So it's 5 of them. 1, 2, 3, 4, 5. So you have the number 5. You have then 5 x's multiplied. Y to the power of 4 is how many y's? 1, 2, 3, 4. And then we have z. And on the bottom we've got the number 30. And then x cubed. So how many x's? 1, 2, 3. And then we have just a y. And how many z's? 2 z's, like that. So we've expanded it all out. And now we can cross cancel, because it's kind of like this. Like if you had something like, I don't know, 10 over, I don't know, like let's say 15. Okay, 10 over 15. That is 5 times 2, isn't it? Over 5 times 3, right? Because 5 times 2 is 10, 5 times 3 is 15. And can't we cross cancel the common factor of 5, right? Right. Similarly here, we're just cross-cancel common factors, numbers that are the same being multiplied. So we can go cross-cancel these x's and they leave 1's, cross-cancel these x's, cross-cancel these x's. But the point is you're left with 2 x's on top, isn't that right? Good. If we cross-cancel the y's, what are we left with? Yeah, 3 y's on top, and then cross-cancel the z's, and we're left with 1 z on the bottom. Right, yep. So, how about 5 into 5 goes once, and 5 into 30 goes 6 times. So, basically, on the top, we've got 1 times 1 times 1 times 1 times x, and x times x makes what? Yeah. Well, you know what, just for fun, I'm just going to write it out. X, and we've got 3 y's, y on the top. And on the bottom, I've got the number 6, and then just a z. That's it, right? And x can be written x squared, and y can be written y to the power of 3. And so we have this. And that's it. Make sense? Now, we could have, if we wanted to, use the quotient rule. What is, and the only thing you need to, well, I guess I'll go step by step. So this is the answer, by the way, everybody. This is the correct answer. Now I'm just going to do the, are you, alrighty. Yeah, so that's that, but just for fun, I'll just quickly go over the quotient rule. Okay, so we're doing the quotient rule. You can do 5 into 5 goes once, 5 into 30 goes 6 times, so we get, well, we get 1 over 6, first of all, right? And then, or 1/6, basically. And then times something, times, this is x to the power of 5 over x to the power of 3. That is, x to the power of 5 minus 3. Sorry for the line through there, it's kind of confusing. And then we have y to the 4 over y. Now, what's the exponent on this y here, if it's just a y in its own? The exponent on this y should be what? 1. So it's y to the power of 1. So this is then times y to the power of 4 minus 1. And then times, and this is on the top, this, and this is on the top, this z should have a exponent of 1, right? So times z to the power of 1, the top one, minus the bottom, 1 minus 2, right? So what we get is 1/6. And x, 5 minus 3, that's x squared. And y to the 4 minus 1, that's y to the power of 3. And z to the power of 1 minus 2, that's z to the power of negative 1, right? And z to the power of negative 1 is actually 1 over z. So what we get is the same thing on the top, x squared y cubed. On the bottom, you know, it's 1/6, so over 6, and this is 1 over z, so z on the bottom. So you end up with the same thing. Although it would probably be easier in this case just to have cross cancel it out, which I kind of prefer when you guys are starting out, that you just you understand what exponents actually mean and stuff. But we can use the quotient rule if we want to as well. Cool. Alright.